There are some additional ways to classify probability. There's unconditional, conditional, as well as complement probability. So unconditional probability is having the denominator be the entire population, so that every person in the sample or population that we are using is eligible to be selected. So the probability that event A will occur. Conditional probability is when you're interested in some subset of the population, so that the denominator isn't the total population, it's the subset total. The symbol shown here as that straight up and down line refers to the fact that we're conditioning on or referring to a specific subgroup to the right of that symbol. So in this example, P, the probability of B subgroup A would be the probability that B will occur given that A occurs, which is conditional. And that's, you can write that out a different way by writing the probability of B with the upside down U, A, divided by the probability of A. Then there's another probability, that's the complement. So the probability of not getting event A is called the complement to the probability of getting event A. And here you would simply take 1 and subtract the probability of getting event A in order to find the probability to not get that event. Here we have an example of some unconditional and conditional questions about probability. So here we have a table of children seen over the past 12 months at a pediatric practice, their age listed as well as their gender, and then the totals. The first question, we want to know what the probability of selecting a boy from that same population. So if we look at the table here, the probability of selecting a boy from the population. So we want to look at the total number of boys divided by the total number of the population. So 2560 divided by 5290. That would be this value that number 1 is asking for. Number 2, what's the probability of selecting a boy who is 10 years of age? So here we have a little bit of a limitation placed on what we're looking at. So we want to know what the probability of selecting a boy who is 10. So that limits us from 2560 down to 418 out of the total sample, so 5290. So if we divide 418 by 5290, we would get this value for number 2. And again, I'm never going to ask you to do this when you wouldn't have access to a calculator. So you would always have access to a calculator for types of questions like this, especially, I mean, in your homeworks, you have take home, so you have all of the resources available to you. Number 3, these are some conditional probabilities now. So what is the probability of selecting a 9-year-old girl from the subpopulation of girls? So if we want to see what the selecting a 9-year-old girl, so that numerator would be 461, but we want to see what the probability is out of the total number of girls in the population. So then we want to look at the total over to the very far right column. So that would be 2730. So if we divide 461 by 2730, we would get this value for number 3. And then number 4, what is the probability of selecting a girl from among the 9-year-old subpopulation? So here we're just looking at this 9-year-old box to start. We want to know the probability of selecting a girl, so that would be this 461 again. And the total number of individuals in that subpopulation is 881. So if we take 461 divided by 881, we would get the answer for number 4. This is another example that's slightly more related to health. So this is showing the number of people with a possible myocardial infarction and angina by smoking status. So we have both infarction and angina in this table, as well as smoking status across the top. So we want to know what the prevalence of angina among ex-smokers, so people that are no longer smoking. So the probability of having angina, so let's first look here at the total number of people. So if we look at possible infarction plus ex-smokers, there's a total of 10 individuals there. If we look at angina and ex-smoker, we have 19 plus 15. Oh, my brain. Sorry, everyone. 19 plus 15. We got to fix that here. Oh. Oh my goodness, everything's just getting erased here. Be 34. Here we go. Now that's a little bit better. So we want to know the prevalence of angina among ex-smokers. So angina, total number of people with angina. Oh, but we just want to know among those who are ex-smokers. So we probably didn't even need to add those together. So 19, the possibility of having angina is 19. Given that we're an ex-smoker, 826. So if we divide 19 by 826, we'll have that answer. Next, what is the prevalence of a possible infarction among those who never smoked? So a possible infarction is 3. Among those who never smoked is 656. So 3 divided by 656, that would give us this answer. The third question is talking about the odds ratio. So what is the odds ratio of ex-smokers for possible infarction as compared to those who have never smoked? So we want to look at ex-smokers for possible infarction as compared to those who never smoked. And then the other thing we're looking at here is possible infarction. Okay. So we want to see the odds ratio. This formula, we haven't learned this yet, but it's just a simple 2x2 table, which I've created for you down here. And I would always give you this information, so you wouldn't have to worry too much. This is cell A, this is cell B, and this is cell C, and this is cell D. And that is what this formula is referring to. So we're going to multiply A times D and divide that by B times C. So here I filled it in. We have 7 times 653 divided by 819 times 3. And this gives us an odds ratio of 1.86. Now I just want to explain where I got these numbers from based on this top table here. So ex-smokers and possible infarction, we already had that as a 7, and possible infarction and never smoked was a 3. Then no possible infarction, so that means all of the rest of these individuals plus the individuals who had had angina. So, minus the number of individuals who had a possible infarction. So if we take 826 and subtract 7, we would have the total remaining people who were ex-smokers but had no possible infarction. So that would be 819. Then to get the never smoked and no possible infarction, we want to take the 656 and subtract 3, which gives us 653, which is cell D here. What the odds ratio is telling us, a 1.86 odds ratio, just means that those with a possible infarction are 1.86 times more likely to have been an ex-smoker compared to those without having a possible infarction. That's how you would write this statement up professionally. So here, this slide just talks about the formulas for odds ratios and relative risk. So these are two different types of commonly used formulas in public health, and you'll learn a lot about them in your epidemiology classes. One important thing to remember is if there's a case control study, you want to be using the odds ratio. And if you're using a cohort study as your model, it would be a relative risk that you want to calculate. Both of the formulas can be calculated from this 2x2 contingency table that I have shown here. And this kind of goes off of the last example with similar, the possible infarction or no infarction, as well as smoking status on the side. So the odds ratio we talked a little bit about on the last slide, and that formula is the A cell times the D cell divided by the B cell times the C cell. And then that would be just how you would summarize your response there. And then the risk ratio or relative risk, or there's a ton of other names for it, but it's always referred to as the RR. It has a different formula that's here. So it's A divided by A plus B, and that whole thing divided by C plus D. So here you'll want to add A. So let's say A was 10. I don't remember what the numbers were. C was 5, B was 10, and D was 20. Let's just do that. So we would have 10 divided by A plus B would be 20. And then that divided by C divided by C plus D, which is 25. So this would come down to 0.5 divided by 1/5, or 0.2. So when we do that, you would get the answer then for the risk ratio. So that's just how you would use these formulas in case you need to use them when you have your homework assignment.